Hello, in this lecture we'll answer on two questions. In the first question, we find out the area of this semicircle that is inside quarter circle A or B. In the second question, we find out the area of this green shape that is inside rectangle ABCD. So we start with the first question. In the drawing, we have quarter circle A or B. We know that side AO of this quarter circle equals to 5 units in itself. That is to say, the radius of this quarter circle equals to 5. And inside this quarter circle A or B, we have this semicircle. And our mission is to find out the area of this semicircle. So first of all, we will define the center of this semicircle. This point is point C. We will define the touching point of the semicircle with this quarter circle. This point is point F. We will define this touching point of the semicircle with the quarter circle. This point is point G. Likewise, we will define the touching point of tangent VO in this semicircle. This point is point H. And finally, we define the point of tendency of tangent AO in this semicircle. This point is point L. In addition, we define the radius of this semicircle as x. So CF equals to x and CG also equals to x. So both the area of the semicircle is equals to x according to our definition. In the next step, we will join point C and H together by a straight line. CH is the radius of this quarter circle that equals to x according to our definition. We join point C and L together by a straight line. CL is also the radius of this semicircle that is equals to x. So here we can implement rule 1 because we have the radius CH, that is 1 to the point of tendency. The radius CH that is equal to x is 1 to the point of tendency, that is point H. And now your radius is 1 to the point of tendency, then tangent VO will be perpendicular to the radius HC. If VO is perpendicular to HC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we have the radius CL that equals to x. The radius CL is 1 to point L, that is the point of tendency of tangent AO in this semicircle. Whenever your radius is 1 to the point of tendency, then tangent AO will be perpendicular to the radius LC. If AO is perpendicular to LC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule, rule 1. So by doing this construction, we can add quadrilateral CL or H. Inside quadrilateral CLOH, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth again. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth again must be equal to 90 degrees in its size. So inside quadrilateral CHOL, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must make this rectangle if not a square. So we write for quadrilateral CLOL as a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So rectangle CLOH, side CL must be equal to the opposite side OH. But CL is x, therefore OH must be also equal to x. Likewise, according to the same rule, in the sum rectangle CLOH, side CH must be equal to the opposite side OL. But CH equals to x, therefore the opposite side OL must be also equal to x. So if we found out that quadrilateral CLOH is not a rectangle but a square, why? Because all of its sides are equal to each other. Each side of the square is equal to x. Extremely simple. In the next step, we'll join points O and C together by a straight line. We join points O and C, can you do? The right and associated triangle CHO. In the next step, we'll copy the right and associated triangle CHO in a new page, and we'll implement the Pythagoras theorem on this right triangle CHO. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the progression for Pythagoras theorem. So actually, this is the right and associated triangle CHO that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle CHO, CO square, that is the square of the hypotenuse, equals to CH square plus HO square. So I'll write it down. CO square equals to CH square plus HO square. CH is the missing side, so we leave it as it is. CO square equals to CH square. CH is x, therefore CH square is x square. Plus HO square. HO is also x, therefore HO square is x square. So in total, CO square equals to x square plus x square, that is 2x square. So CO square equals to 2x squared. Here we take out of this equation. And finally we get that CO equals to the square root of 2 times x units in its length. So if we found out that the length of this 97 CO equals to the square root of 2 times x units, so we know that this is point O, that is the center of the quarter circle. So from the center of the quarter circle, this is to say from this point O, we have here line segment OC that bisects chord FG. Why line segment OC bisects chord FG? Because line segment OC actually divides chord FG into two halves. Each half equals to x. CF equals to x, and the other half CG also equals to x. So remember, you have a line segment that is drawn from the center of the circle and bisect the chord. You can implement rule 7. So I'll please click on rule 7. According to rule 7, if a line segment that is drawn from the center of the circle bisect the chord, then the line segment is also perpendicular to that chord. So in the drawing you have a circle, and this is point O, this is the center of this circle. From this point O, we have line segment OM that bisects chord AB. That is to say, MA equals to MB. And therefore, line segment OM will be also perpendicular to AB. If OM is perpendicular to AB, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule 7. So we can actually implement rule 7 in our drawing. Why? Because in our drawing, from the center of the quarter circle, that is to say from this point O, we have here line segment OC that bisects chord FG. That is to say CF equals to CG. So all the requirements of rule 7 are satisfied, and therefore we can implement here rule 7. According to rule 7, line segment OC will be also perpendicular to FG. If line segment OC is perpendicular to FG, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 7. In the next step, we will join points O and F together by a straight line. We know that the radius of this quarter circle equals to 5, because AO is the radius of the quarter circle, and it is given us a question that AO equals to 5. So the radius of this quarter circle equals to 5 units in its length. So what is the definition of line segment OF? Line segment OF starts from point O, that is the center of the quarter circle, and that's at point F, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore OF is the radius of this quarter circle, that is equals to 5. So in the next step, I'll copy the right and green triangle CFO in a new pen, and we will implement the Pythagoras theorem in this right triangle CFO. Here by PT is a proportion from Pythagoras theorem. So actually, this is the right and green triangle, triangle CFO that I copied from the original drawing. According to the Pythagoras theorem, this right triangle, triangle CFO, FO squared, that is the square of the hypotenuse, equals to FC squared plus CO squared. Again, FO squared equals to CF squared plus CO squared. So I'll write it down. FO squared, that is the square of the hypotenuse, equals to FC squared plus CO squared. FO, the hypotenuse FO equals to 5 units in its length, therefore FO squared is 5 squared, that is 25. And it equals to FC squared. FC is x, therefore FC squared is x squared plus CO squared. CO is equal to 2 times x units in its length, therefore CO squared will be equal to 2 times x squared. So in total we found out that 25 equals to x squared plus 2x squared, that is 3x squared. So 25 equals to 3x squared. Here we divide this equation by 3. And finally we get that x squared equals to 25 over 3. Our mission is to find out the area of this semicircle. We know that the radius of this semicircle is x, and therefore the area of this semicircle must be equal to pi x squared over 2. So the area that we are looking for is the area of the semicircle is equals to pi x squared over 2. X is the radius of the semicircle. So the area of the semicircle equals to pi over 2 times x squared. And just right now found out that x squared equals to 25 over 3. So we can substitute x squared in this equation by 25 over 3. We do it now, and we get that the area of the semicircle in total will be equal to pi over 2 times x squared. And x squared is 25 over 3. So in total, the area of the semicircle equals to, in the numerator of this expression we have 25 pi. In the denominator we have 2 times 3, that is 6. So in total we should find out that the area of this semicircle equals to either 25 pi over 6 square units, or in terms of numbers it is equals to 13.09 square units. And that is the answer to the question. And again, if we found out the area of this semicircle equals to either 25 pi over 6 square units, or in terms of numbers, the area of this semicircle equals to 13.09 square units. So we finished with the first question. In the next step, I'll present you the second question and we'll solve it. So in the second question, our mission is to find out the area of this green shape. So in the drawing, we have rectangle ABCD. We know that side AB of this rectangle ABCD equals to 5 units in its length. inside this rectangle ABCD we have this semicircle and this quarter circle. Again, our mission is to find out the area of this green shape. So, in the first step, we will define the radius of this quarter circle as x. Therefore, BC, this is the radius of this quarter circle, equals to x according to our definition. We know that all the angles inside any rectangle are right angles. And therefore, angle ADC is a right angle. In addition, we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABCD, side AB equals to the opposite side DC. But AB is 5, therefore DC must be also equal to 5 units in its length. So I want to know DC equals to 5 units in its length. Likewise, according to the same rule, in the same rectangle ABCD, side BC must be equal to the opposite side AD. But BC is x, therefore AD must be also equal to x. AD is one side of rectangle ABCD, but AD is also the diameter of this semicircle. So we know that the diameter of this semicircle AD equals to x. If the diameter is x, then the radius must be equal to half of it. That is to say, the radius of this semicircle must be equal to x over 2 units in its length. We define the center of this semicircle, this point is point O. So the radius AO of this semicircle equals to x over 2 units in its length. And the radius OD also equals to x over 2 units in its length. In the drawing, we have an external arch between the semicircle and the quarter circle. That is to say, they touch each other externally at this point. We define this point that is the touching point as point S. So, in the drawing, we have an external arch between the semicircle and the quarter circle. And whenever you have an external arch between two circles or semicircles or quarter circles, you can implement rule 10. So I repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes through their touching points. So in the drawing, we have two circles and they touch each other externally at this point, point P. The center of this circle is at point O. The center of this circle is at point M. And the straight line that connects the centers together is of course the straight line OM, and this straight line OM, according to this rule 10, must pass through point P, that is the touching point. Again, the straight line OM must pass through the touching point, that is point P. Or OPM is one straight line. Again, OPM is one straight line according to this rule 10. So we can actually implement rule 10 in our drawing. Why? Because in our drawing, we have an external arch between the semicircle and the quarter circle. The center of this semicircle is at point O. The center of this quarter circle is at point C. And the straight line that connects the centers together, the straight line that connects the centers together is of course the straight line OC. And according to rule 10, the straight line OC must pass through the touching point, that is point S. Again, the straight line OC, according to rule 10, must pass through point S, that is the touching point. So we connect and join points O and C together by straight line, and we know that the straight line OC must pass through point S, that is the touching point. From drawing, it's very easy to see that the third line OC passes through point S, that is their touching point. The touching point between the semicircle and the quarter circle. Or OSC is one straight line. OSC is one straight line. If OSC is one straight line, it means that OC equals to OS plus SC. Again, OC equals to OS plus SC. So I write it down. OC equals to OS plus SC. So OC equals to OS. OS is the radius of this semicircle, is equals to x over 2 units in its length. So OS equals to x over 2 plus SC. SC is the radius of this quarter circle, that is equals to x. So in total we found out that OC equals to x over 2 plus x, that is 1.5x, or 3 over 2 times x units. So if we found out that OC equals to 3 over 2 times x units in its length. So write it down here, OC equals to 3 over 2 times x units in its length. So in the next step, I'll copy the right triangle ODC in a new page and implement the Pythagoras theorem with this right triangle ODC. Here by PT is a progression for Pythagoras theorem. Actually, this is the right triangle ODC that I copied from the original drawing according to the Pythagoras theorem. This right triangle ODC, OC square equals to OD square plus DC square. So I write it down. OC square, that is the square of the hypotenuse, equals to OD square plus DC square. The hypotenuse OC equals to 3 over 2 times x units in its length. Therefore OC square is 3 over 2 times x squared, that is actually 9 over 4 times x squared. 9 over 4 times x squared, or 9 quarters times x squared, and it is equals to OD square. OD is x over 2, therefore OD square is x over 2 squared, that is x squared over 4. Plus DC square. DC is 5, therefore DC square is 5 squared, that is 25. So in total we found out that 9 quarters x squared equals to 1 quarter x squared plus 25. Here we subtract x squared over 4 from this equation. And finally we get that 9 quarters x squared plus 1 quarter x squared equals to 8 quarters x squared, and it equals to 25. So 8 quarters x squared equals to 25. 8 over 2, 8 over 4 is 2. So this expression equals to 2x squared. So if I found out that 2x squared equals to 25. Here we divide this equation by 2 and finally get that x squared equals to 25 over 2. So here we take a root out of this equation and finally we get that x equals to the square root of 25 is 5 over square root of 2. So x equals to 5 over square root of 2 is in its name, and x squared equals to 25 over 2. Our mission is to find out the area of this green shape. So what is the area of the green shape? For the moment, it is very easy to see that the area of this green shape equals to the area of rectangle ABCD minus the area of this semicircle minus the area of this quarter circle. So I write it down, the area of the green shape equals to the area of rectangle ABCD minus the area of this semicircle minus the area of this quarter circle. Repeat again, we should find out that the area of this green shape equals to the area of the green shape equals to the area of rectangle ABCD minus the area of the semicircle minus the area of the quarter circle. So what is the area of rectangle ABCD? The area of a rectangle equals to the length of the rectangle times the width. The length of this rectangle ABCD is AB, that is 5, times the width. The width is BC, that is x. So total the area of this rectangle ABCD equals to 5x. And also here minus the area of the semicircle. What is the area of this semicircle? You know that the radius of this semicircle is x over 2. Therefore the area must be equal to pi times the radius squared, that is pi times x over 2 squared divided by 2. So right now the area of the semicircle equals to pi times the radius squared. The radius is x over 2 squared divided by 2. Minus the area of the quarter circle. What is the area of this quarter circle? We know that the radius of this quarter circle is x. Therefore the area must be equal to pi x squared over 4. So the area of the quarter circle equals to pi x squared over 4. So actually the value of this expression between the markers, is equal to the area of the green shape. So what is the value of this expression? The value of this expression equals to 5x. Here we have minus pi times x over 2 squared over 2. So it is pi times x over 2 squared. X over 2 squared equals to x squared over 4 divided by 2. So in total we found out that the value of this expression equals to pi x squared over 2 times 4 minus pi x squared over 4. So the area of the green shape equals to 5x. Here we have minus pi x squared over 2 times 4, that is 8. So in total this expression equals to minus pi x squared over 8. Here we have minus pi x squared over 4. So here we divide both the numerator and the denominator of this expression by 2. in order to overcome a factor with this expression. So the value of this expression, after multiplied both the numerator and the denominator by 2, will be equal to minus 2 pi x squared over 8. So the area of the green shape in total equals to 5x minus pi x squared over 8 minus 2 pi x squared over 8 equals to minus 3 pi x squared over 8. So in total we found out that the area of the green shape equals to 5x minus 3 pi x squared over 8. But we already found out that x equals to 5 over square, x equals to 5 over square root of 2 units in its length, and x squared equals to 25 over 2. Therefore, we can substitute x in this expression by 5 over square root of 2, and x squared this expression by 25 over 2. We do it now, we get that the area of the green shape in total equals to 5x, and x is 5 over square root of 2 minus 3 pi over 8 times x squared, and x squared is 25 over 2. So in total we found out that the area of the green shape equals to, here we have 5 times 5 is 25, so in total the value of this expression is equals to 25 over square root of 2, and here we have this expression. The value of the numerator of this expression is 3 pi times 25, that is, or minus 3 pi over 25, that is minus 75 pi, divided by 8 times 2, that is 16. So if we found out that the area of the green shape in total equals to 25 over square root of 2, 175 pi over 16 square units. On terms of numbers, the value of this expression is equal to 2.95 square units. And that is the answer to the question. Repeat again, if we found out that the area of this green shape equals to 2.95 square units. So finish with the second question. In the next step, I summarize the lecture. Let's start with the first question, of course. So, in the first question, our mission was to find out the area of this semicircle that is inside quarter circle AOB. So, in the drawing, we have quarter circle AOB. We know that AO equals to 5 units in length. That is to say, the radius of this semicircle equals to 5. In addition, inside this quarter circle AOB, we have this semicircle, and our mission is to find out the area of this semicircle. So in the first step, we define the center of this semicircle. This point is point C. Likewise, we define the touching point between the semicircle and the quarter circle. This point is point F. We define the other touching point between the semicircle. This point between the semicircle and the quarter circle is G. Likewise, we also define the point of tendency of tangent BO with this semicircle. This point is point H. And finally, we define the point of tendency of tangent AO with this semicircle. This point is point L. In addition, we define the radius of this semicircle as x. Therefore, CG equals to CF equals to x. The above the area of the semicircle is equal to x. So, in the next step, we join points. We join points C and H together by straight line. C edge is the radius of the semicircle that equals to x. Likewise, we join point C and M together by straight line. CL is also the radius of the semicircle that equals to x. By doing these constructions, we can do quadrilateral CLOH. Inside this quadrilateral CLOH, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 angle. In total, the must be equal to 360 degrees according to the rule that says that the sum of the angles on one side, the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this 4 angle must be equal to 90 degrees in size. So inside quadrilateral CLOH, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least right angle times a square. So we will write to quadrilateral CLOH as a right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So in right angle CLOH, side CL must be equal to the opposite side OH. But CL is x, therefore OH must be also equal to x. Likewise, according to the symbol in the same rectangle CLOH, side CH must be equal to the opposite side OL, but CH is x, therefore OL must be also equal to x. So if we found out that quadrilateral CLOH is not a rectangle but a square, because of the fact that all of its sides are equal to each other. Each side of this square is equal to x. In the next step, we join points O and C together by a straight line. By joining points O and C, we can do the right and associated triangle CHO. So copy this right triangle CHO in your page and implement it by the rest of this right triangle CHO. Okay, this is the right and associated triangle CHO that is going from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse in this right triangle CHO is CO, therefore the square of the hypotenuse is CO square, and it must be equal to CH square plus OH square. Again, CO square equals to CH square plus OH square. CO is the missing side, so we leave it as it is, so CO square equals to CH square. CH is x, therefore CH square is x square plus HO square. HO is also x, and therefore HO square is x square. So in total, if you found out that CO square equals to x square plus x square, that is 2x square. So CO square equals to 2x square. Here we took out of this equation and finally found out that the length of the hypotenuse CO is therefore equals to square root of 2 times x. Okay, this is the hypotenuse CO that is equals to the square root of 2 times x units in its length. So here we know that point O is the center of the quarter circle. So from this point O that is the center of the quarter circle, we have here line segment OC that bisects chord FG. This is to say, line segment OC divides chord FG into two halves. Each half equals to x. So CF equals to x and CG also equals to x. And whenever you have a line segment that is drawn from the center of the circle or semicircle or quarter circle and it bisects the chord, then you can implement rule 7. So I can click on rule 7. According to rule 7, if a line segment that is drawn from the center of the circle bisects the chord, then the line segment will be also perpendicular to that chord. So in the drawing you have a circle, and this is point O, that is the center of the circle. So from this point O, that is the center of the circle, we have here line segment OM that bisects chord AB. This is to say MA equals to MB. And therefore, according to this rule 7, line segment OM will be also perpendicular to AB. If OM is perpendicular to AB, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule 7. So we can actually implement rule 7 in our drawing. Why? Because in our drawing, from the center of this quarter circle, that is to say from point O, we have line segment OC that bisect chord FG. So all the requirements of Rule 7 are satisfied, and therefore we can implement Rule 7. According to Rule 7, line 7 OC will be also perpendicular to FG. If OC is perpendicular to FG, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to Rule 7. In the next step, we join points O and F together by side line. OF is the radius of this quarter second, that is equals to x. Why? Because it starts from point O, that is the center of the quarter second, and then the point F, that is the point on the quarter second itself. So this is exactly the definition of a radius. Therefore, OF is the radius of the quarter second, that is equals to 5. In the next step, according to the right angle triangle CFO in the new page, and we implemented the Pythagoras theorem in this right triangle CFO. So this is the right angle triangle CFO, the proof from the original drawing, according to the Pythagoras theorem in this right triangle CFO. FO square, that is the square of the hypotenuse, equals to CF square plus CO square. Again, FO square equals to CF square plus CO square. FO is 5, therefore FO square is 5 square, that is 25. This is equals to CF square. CF is x, therefore CF square is x square plus CO square. CO is equal to 2 times x, therefore CO square will be equal to 2x square. So in total, 25 equals to x square plus 2x square, that is 3x square. So 25 equals to 3x square. Here we divided this equation by 3, and finally found out that x square equals to 25 over 3. Our mission is to find out the area of this semicircle. We know that the radius of this semicircle is x. The radius of this semicircle is x, and therefore the area must be equal to pi x square over 2. So again, the area of the semicircle equals to pi x square over 2. And we just find out, so it is pi over 2 times x square. We just like now found out that x square equals to 25 over 3, therefore we can substitute x square in this equation by 25 over 3. We did it, and we found out that the area of the semicircle in total equals to pi over 2 times x square, and x square is 25 over 3. So in total, the area of the semicircle equals to the value of this expression, that is actually 25 pi over 2 times 3, that is 6. So in total, we found out that the area of this semicircle equals to either 25 pi over 6 square units, so in terms of numbers, the area of this semicircle equals to 13.09 square units. So we finished with the first question. In the next step, we present the second question, and we solve the second question. In the second question, our mission is to find out the area of this green shape. So in the drawing, we have rectangle ABCD. We know the side AB of this rectangle ABCD equals to 5 units in its length. In addition, inside this rectangle ABCD, we have this semicircle and this quarter circle. Again, our mission is to find out the area of this green shape. So first of all, we define the radius of this quarter circle, BCP, as x. And we also know that all the angles inside a rectangle are right angles. So this angle ADC inside a rectangle ABCD must be equal to 90 degrees in its size. And we also know that the opposite sides of a rectangle are equal to each other. So a rectangle ABCD, side BC must be equal to the opposite side AD. But BC equals to x, therefore AD must be also equal to x. AD is one side of rectangle ABCD, but AD is also the diameter of this semicircle. So we know that the diameter of this semicircle equals to x. If the diameter is x, it means that the radius must be equal to half of it. So the radius of this semicircle must be equal to x over 2 units in itself. We define the center of the semicircle, this point as point O. So the radius OA of the semicircle must be equal to x over 2 units, and the radius OD must be also equal to x over 2 units in its length. So here we have also not again the opposite sides of an octagon are equal to each other. So an octagon ABCD, side AB must be equal to the opposite side DC, but AB is 5, therefore DC must be also equal to 5. So in the drawing we have an external notch between this semicircle and this quarter circle. That is to say, they touch each other externally. In this point S. And whenever you have an external notch between two circles, or semicircles, or quarter circles, you can implement rule 10. So I'll repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes for their touching points. So in the drawing we have two circles, and they touch each other externally in this point P. So they have an external notch between them, it's point P. The center of this circle is at point O. The center of this circle is at point M. And the straight line that connects the centers together is of course the straight line OM. And according to this rule 10, the straight line OM must pass for their touching point, that is point P. Again, the straight line OM must pass for point P, that is their touching point. Or OPM is one straight line. Again, OPM according to this rule 10, OPM is one straight line. So we can actually implement rule 10 in our drawing. In our drawing, we have external notch between this semicircle and this quarter circle. That is to say, they touch each other externally in this point S. We know that the center of this semicircle is at point O. The center of this quarter circle is at point C. And the straight line that connects the centers together is of course the straight line OC. And according to rule 10, the straight line OC must pass through point S, that is their touching point. Again, the straight line OC must pass through their touching point, that is point S. Or OSC is one straight line. Again, OSC is one straight line according to rule 10. If OSC is one straight line, it means that OC equals to OS plus SC. Again, OC equals to OS plus SC. OC equals to OS plus SC. So OC equals to OS. OS is the radius of this semicircle, that is equals to x over 2, plus SC. SC is the radius of this quarter circle, that is equals to x. So in total, OC equals to x over 2 plus x, that is 1.5x, so 3 over 2 times x units in itself. So if you found out that the value of the opposite OC is 3 over 2 times x units. So in the next step, I copied the right triangle ODC in an page and implemented the Pythagoras theorem on this right triangle ODC. So actually, this is the right triangle ODC that according to the original drawing, OD equals to x over 2, DC equals to 5, and the opposite OC equals to 3 over 2 times x units in its length. This right triangle ODC according to the Pythagoras theorem, OC square equals to OD square plus DC square. Again, OC square equals to OD square plus DC square. OC is 3 over 2 times x, therefore OC square will be equal to 9 over 4 times x square. And it is equal to OD square. OD is x over 2, therefore OD square is x square over 4 plus DC square. DC is 5, therefore DC square is 5 square, that is 25. So in total, we should found out that 9 quarters x square equals to 1 quarter x square plus 25. Here we subtract x square over 4 from this equation, and finally found out that 9 quarters x square minus 1 quarter x square equals to 8 quarters x square, and this is equals to 25. So x square over 4 minus x over 4 is 0. So if we found out that x square, 8 quarters times x square equals to 25. 8 over 4 is 2, so this expression equals to 2x square, so 2x square equals to 25. Here we divided this equation by 2 and finally found out that x squared equals to 25 over 2. So here we took out of this expression and finally found out that x equals to the square root of 25, that is 5, or the square root of 2. So if we found out that x equals to 25 over 2 and x equals to 5 over square root of 2 is in its length. Our mission is to find out the area of this green shape. So what is the area of the green shape? From the drawing it is easy to see that the area of this green shape equals to the area of rectangle ABCD minus the area of this semicircle minus the area of the quarter circle. Okay, again, the area of the green shape equals to the area of rectangle ABCD minus the area of the semicircle minus the area of the quarter circle. So what is the area of rectangle ABCD? The area of any rectangle equals to the length of the rectangle times the width. The length of rectangle ABCD is AB, that is 5, the width is BC, that is x. So in total, the area of rectangle ABCD equals to 5x. So again, the area of rectangle ABCD equals to 5x. Minus the area of this semicircle. What is the area of this semicircle? We know that the radius of this semicircle is x over 2. So the area of the semicircle equals to pi times the radius squared over 2. So it is pi times x over 2 squared divided by 2. The area of the semicircle equals to pi times x over 2 squared divided by 2. Minus the area of the quarter circle. We know that the radius of this quarter circle is x, therefore the area of this quarter circle must be equal to pi x squared over 4. Again, the area of the quarter circle equals to pi x squared over 4. So the value of the expression that is between those two brackets is equals to the area of the green shape. So what is the value of this expression? It is equals to 5x, and here we have pi times x over 2 squared. X over 2 squared equals to x squared over 4 divided by 2. So in total the value of this expression equals to pi x squared over 2 times 4 minus pi x squared over 4. So the area of the green shape equals to 5x, and here we have pi x squared over 2 times 4. 2 times 4 is 8, so in total the value of this expression is pi x squared over 8 minus pi x squared over 4. So here we have pi x squared over 4, so here we multiply both the numerator and the denominator of this expression by 2, and after multiplying it by 2, we shall find out that the value of this expression will be equal to 2 pi x squared minus 2 pi x squared over 8. So in total the area of the green shape equals to 5x, and here we have minus pi x squared over 8 minus 2 pi x squared over 8 equals to minus 5 pi x squared over 8. So in total the area of the green shape equals to 5x minus 5 pi over 8 times x squared. But we already found out that x equals to 5 over square root of 2 and x squared equals to 25 over 2. Therefore, we can substitute x in this expression by 5 over square root of 2, and we can substitute x squared in this expression by 25 over 2. We did it, and we found out that 5x is 5 and x is 5 over square root of 2, minus 3 pi over 8 times x squared, and x squared is 25 over 2. So in total we found out that the area of the green shape equals to 5 times 5 is 25, so in total the value of this expression is 25 over square root of 2, minus, here we have the numerator of this expression is minus 3 pi over 25 minus 75 pi divided by 8 times 2, that is 16. So in total we found out that the area of the green shape equals to 25 over square root of 2 minus 75 pi over 16 square units. Or the value of this expression in total it will be equal to 2.95. So if you found out that the area of this green shape equals to 2.95 square units. Okay, thank you very much.